Welcome to All This Math. This is Professor Parker, and today we're going to graph some linear equations, but these are what I call some special case linear equations, right? These linear equations don't get a lot of buzz. They don't really get a lot of attention, but you will see them. You'll see them on a classwork assignment. You'll see them on a quiz. You might see them on a standardized test, and they don't look like the regular linear equations that you're asked to graph. So then you're going to see them and be like, whoa, what am I supposed to do with this, right? So what I'm going to do is I'm going to show you how to graph these. So then when you see a linear equation that looks like one of these, it'll be nothing. It'll be nothing to it. You'll already know what to do. So, case in point, look at number one up here, right? This says y equals negative 3/2 x, right? Now, I did a recent video where I was talking about the first question you should ask yourself is, what form is it in, right? Is it in standard form, ax plus by equals c, or is it in slope-intercept form, which is y equals mx plus b, right? Now, when you look at number one, it says y equals negative 3/2 x. Now, whenever you have the y equals, that's a dead giveaway. That's going to basically tell you that it's in slope-intercept form. But here's the issue, though. If I write slope-intercept form down, the general form is this. Y equals mx plus b. I got a y and I got a y. My y's match up. My equal signs match up. My m in this negative 3/2, that matches up. So I know what my slope is. These x's match up. But, oh, where's my b at? It's nothing after the negative 3/2 x. Where's my b? So a lot of people get nervous and they say, oh, what am I supposed to do? What am I supposed to do? Check this out. If there's ever no number written after that, no number, we look at that as a zero. We just look at it as a zero, straight like that. So that means that in this case, b is 0. All right? So in this situation, we know m is negative 3/2, and we know b is 0. So whenever you are given a linear equation that's set up like this, y equals some number times x, and that's it, and it's no plus nothing, it's no minus nothing after that, that means that b equals 0. b equals 0. Keep that in mind. That means that b equals 0. So that means that the y-intercept is right there at the origin. Right there at the origin. That's what that means. Because again, the y-intercept is the value of y when x is 0. So if x is already 0, and then y is 0, that means your point is 0, 0. All right? So whenever you see that, whenever you just see y equals the number times x, nothing after it, right? That means that your y-intercept is 0. So you always start with your y-intercept, right? So if we start with our y-intercept, let me grab the green drawing. I'm going to plot that right here. That's my y-intercept. All right? So now you know how to do it. Now when you see that, you'll recognize and say, oh yeah, I watched the All This Math video and they said when there's no number after the x term, that just means b is 0. Cool. Now we're going to use our slope though. So the slope was negative 3/2. Now, when I rewrote it, this is a force of habit. I put the negative sign with the numerator. And you can do that because when the whole fraction is negative, that means that either the numerator or the denominator is negative. Not both, but one or the other. And if one is negative, that means the other number is positive. So that makes this a positive 2. Now, if the numerator is negative 3, that means that I need to move down because the numerator tells me how I should move vertically, whether I should move up or down and by how many spaces. So that means I'm going to move down 3 spaces from the y-intercept, and then I'm going to move to the right 2 spaces from that point, right? So I start here, and I go down like 1, 2, 3. Then I slide to the right 2 spaces, 1, 2. And that's where I stop. And I draw my point. Now I got my 2 points. Now I need a minimum of 2 points in order to graph a line. So I'm going to do this. I missed the point, but this is approximate anyway. You know what I mean? It's approximate, right? So that's my graph. That's y equals negative 3/2 x. Another thing I want to point out to you is this. You know the line was going to go downhill. And when I say downhill, that depends on perspective. That's a matter of perspective because if I'm looking at it going from the right to the left, this looks like it's going uphill. But when we're looking at these graphs, we're looking at it from the perspective of looking at it from left to right. The same way we read in the English language from left to right, we're looking at it from left to right. And looking at it from left to right, it's going downhill. And I knew it was going to go downhill because my slope is negative. Another thing I want you to put down in your notes, whenever your slope is negative, your line is going to go downhill. So if you're graphing something and you got a line that's downhill, but your slope is positive, then you need to check for an error. You made a mistake somewhere. All right? Because whenever your slope is negative, your line should be going downhill. Looking at it from left to right, your line should be going downhill. Whenever your slope is negative. When your slope is positive, conversely, your line should be going uphill. All right? It should be slanted, going uphill. All right? Now that we're done with that, number one. Now look at number two and number three. Number two and number three are two more special cases that you will see. Here you just have x equals a number. All right? Now, put this in your notes. Whenever you see x equal to a number and there's no y variable at all, that is a vertical line. That is a vertical line, and the slope is undefined. Those are two things you need to remember, two key pieces of information. This is a vertical line, and the slope is undefined. All right? So now, what that means is, all I do is I find 4 on the x-axis, because this says x equals 4, or x is 4. So I go to the x-axis, right, which is the horizontal axis. And then I go 1, 2, 3, 4. And then it's not marked. Okay, well, all right, about to say. Yeah, so here's my point, right? Now, it's a vertical line because if x is 4, that means x is always going to be 4. The x value is always going to be 4. It doesn't matter what the y value is. The x value is always going to be 4 no matter what. So up here, I could put a point up here. This is, let me see, 4 and, what's the coordinates to this? 4 and 1, 2, 3, 4. Coordinates to this is 4 and 0, right? It don't matter, like the x value is always going to be 4. That's why the equation is x equals 4. So whenever you see an equation where you have x equal to a number, it's a vertical line and it goes through that number on the x-axis. All right? So let's draw this. That's x equals 4. So just try to remember that. That's another special case equation, linear equation that you will have to graph. All right? Now, last but not least, the third example, we have y equals -2. Now, when you have y equal to a number, you could probably guess what it's going to look like because you know what x equal to a number looks like. When you have y equal to a number, that's going to be a horizontal line with a slope of 0. A horizontal line with a slope of 0. Now, all I got to do is I got to find -2 on the y-axis because this says y is -2. So I find -2. -2 is right here. -2 is right there. Right? So -2 is right there. And now we just draw a line. If I could put the point, go straight across like that. And then we got y equals -2. All right? So these are three like just kind of equations that are easy to graph, but if you haven't been taught, right? Like I just showed you like how to graph them and what to think about when you see them, then when you see them, you'll be confused. So these are like some of the fundamental aspects, some of the like, the blind spots that a lot of people have because they haven't been like explicitly taught. Like how do you graph a linear equation where there's no numerical b value written? That just means that b equals 0, right? And if, somebody had just told you that, then you would have knew how to graph it, right? But a lot of times, nobody might not have told you that. Or maybe somebody told you that, but you forgot because you were so overwhelmed with so many different mathematical details that that's just something that you forgot. So I'm here to remind you, right? When you don't see a number after -3/2 x, that means that b is 0. And if b is 0, that means that the y-intercept is at the origin. And then you use your slope to get to the next point. Remember, the slope is not a point. The slope is a set of directions to get to the next point, and the next point, and the next point, and the next point. No matter how many, depending on how many points you actually want to plot. Now, number 2, x equals 4. Whenever you have x equal to a number, that's a vertical line, straight up and down. It's a vertical line, right? Straight up and down like 6 o'clock. It's a vertical line, all right? So I'm over here with it. I find 4 on the x-axis. I plot that point, and then I draw a vertical line. That's what I do. Now, whenever you see y equal to a number, no matter what the number is, you find that number on the y-axis. In this case, y was equal to -2. So I found -2 on the y-axis, which was right there, and you draw a horizontal line. Now, this means that y is always going to be -2. And the only way that y could always be -2 is if this is a horizontal line that goes through points that always have a y value of -2. All right, so that's about it for now. And please like the video, subscribe to the page, share the video, tell some people about it, and always remember that there's all this math all around you.